grade would be my guess when you might see square roots.
I remember the first time I ever saw square roots, not solving them and seeing them, was like third grade.
So if I said to you, really difficult question, what's the square root of 25? What is it? Okay. It's square root of 25 is 5. Why? Because you're asking yourself what number times itself makes 25. Okay, and you're going to get 5. But couldn't the answer also be negative 5?
Yep.
Because is it negative 5 times itself 25?
Yep.
Okay, so why don't we give both answers?
Because
That's just un-American.
Because some mathematicians in the deep dark past said when we do square roots, we're going to give the principal root, which is the positive answer. We're not going to give the negative answer. So it is normally assumed that square roots will have positive results. Okay, not only is that true of square roots, now we're going to do cube roots and fourth roots and 10th roots and 100th roots and any other kind of root we could want to do. Okay, any root that's a positive, or excuse me, is an even number, second, fourth, gentlemen, need to tune in. Any root that's even, second, fourth, sixth, eighth, 10th, 12th, all even roots are supposed to end up as positive numbers. So now, do you know how to read this? Okay, it's a cube root of 8. So what's it mean when you're doing a cubed root? What number times itself 3 times makes 8? And several of you just said that, yeah, 2 times 2 times 2 makes 8. So yeah, the cube root of 8 is 2. Question, what's the cube root of negative 8? Okay, we had i's when we were doing square roots. I's are only when you are doing square roots. You do not get i's from anything else. But what times itself 3 times is negative 8?
oh wait, it's an odd.
Since it's an odd number, it's an odd root, cube root. Isn't negative 2 times itself 3 times? 3 negatives are going to turn out to be a negative. So you can have negative numbers in odd roots. It's okay. You can have negative numbers in odd roots, you'll get a negative answer. If you have a square root, technically doesn't have a little number up here, which, by the way, we need to talk about that. That little number up there is called the index. So the little cube we put on the cube root, that's the index. Okay. Well, square roots actually should have an index, but mathematicians got lazy. Because we use square roots so much, way more than in the others, they said, we are not going to bother to write it. Technically, there should be a little 2 up there on a square root. But they said, okay, we're not going to write that all the time. If you see a root written and it has no index on it, it's automatically a square root. But technically, there should be a 2 there. Okay. Does anybody remember what the quantity inside the root's got a name? What's it called? This is mostly a Scholars Bowl question.
Wait.
It starts with R.
Radical.
Nope. It's the radicand. The radical is the sign itself, is the root symbol. That's the radical sign. So the radicand is actually the quantity inside the root. Okay. For the most part, we don't get too excited about that terminology. Okay, so now I need to take you back to basic root stuff we already know. Double checking here. If I said, what's the square root of 49, what do y'all tell me? 7. If I said, what's the cube root of negative 125? What do you tell me? What times itself 3 times makes a negative 125? It would be negative 5. Okay, but what if I said, hey dudes, what's the 6th root of 64?
2.
Okay, well that's where it might come in helpful to be able to read your little pink chart I just gave you. Okay? You'll notice it's got down the side the numbers 1 through 20, and then going across the top, it tells you what all the squared numbers are, what all the cubed numbers are, 4th, 5th, and up to the 6th power. So in this case, if you go to the x to the sixth column and find 64, what number was taken to the sixth power to get 64? 2. Follow clear to the left edge. 2 to the sixth was 64. So therefore, if you're asked for the sixth root of 64, it's 2. Okay, what if I ask you for the fifth root of 1024? You would go to the x to the fifth column, you would then find 1024, and then come across 4 was the number we took to the fifth power. So yes, the answer is 4. Okay, I'm not going to give you numbers any bigger than these, and most of the time I'm not even going to give you numbers that big.
Should we do this on a test?
I usually don't let you do it on the test. On the test, I keep small numbers. I won't give you something like 1024.
Could you still let us do it on the test?
What's small considered small? Like
Wait,
104,000?
okay, 125 I consider small.
Wait, so you won't allow calculators, will you?
You're allowed to calculate it, yeah.
Okay.
So you can figure it out with your calculator.
Is it a lot?
Can you do something this way,
Okay. Where this gets interesting, let me take you back to October. How did 24 doesn't have a perfect square root? What did we do to break down 24? We had to find two numbers that made 24. One of them has to be a perfect square. And we knew 4 was a perfect square number. So when we took the 4 out, it became, square root of 4 was 2, and the 6 had to stay inside. It didn't get to come out and play. So again, yes, can you do that with other roots? Absolutely. If I said break down the cube root of 40, and this is mostly why I gave you the pink sheet. Look down your cubed column. Find a number that multiplies to make 40. 8. Is an 8 a factor of 40? So you could turn 40 into 8 times 5. What's the cube root of 8? What times itself 3 times makes 8? 2. So you would take the 2 out and you would leave the cube root of 5 in there. Okay. So you need to do a few of those. That takes a little bit of sinking in. Okay, suppose I said find me the fourth root of 162. If you go down the fourth column, next to the fourth column, you won't find 162. But does one of those numbers in the x to the fourth column multiply and make 162? I got to vote for 81. 81 times what?
2.
81 times 2 is 162. Look down your x to the fourth column. If you look down the x to the fourth column, does 16 go into 162 evenly? No. Does 81 go into 162?
Oh, you're looking on x to the fourth.
Yeah.
I was going down 4.
No, you're going down x to the fourth. Okay, so if you go down that column, so what's the fourth root of 81?
8, 9,
What times itself 4 times makes 81? So in the x to the fourth column, 81, go over, it's 3. So 3 comes out and you're left with a fourth root of 2 on the inside. It's not too bad. Like I said, I'm not going to go hogwash crazy on big numbers.
One more.
Yes, I can. Okay, here's a big mama one for you. What's the sixth root of 3,645?
3,000?
Okay, so you're going to which column? X to the sixth. You're going down the x to the sixth column, and you got to find a number that would multiply to make 3.
Oh, well, there's a 5 on the end.
There's a 5 on the end. You're right.
It's not on here.
Okay, so 64 can't go into it because 64.
729 then.
729 times 5 is, no, you play with your calculator and you find a number that works. Okay, so now, when I take 729 out, what does it become? 3, because 729, if you go over, it's 3 to the 6th power. So you would have 3 times the 6th root of 5. Now the hardest part you're going to find yourself is you got to remember to write that index on your answers. If you don't put that little 6 there, you're doing square root of 5. That totally changes the answer. So you really got to watch that you write the index on your root.
How do you put the index in?
Your calculator has the option to put the index in. If you do the root with a little spot on it, we'll get to that. All right, that's numbers. Variables. How do you do this with variables? It's actually easier, in my opinion, to do it with variables.
Actually, it might be.
Okay, we're going to start basic here. What's the square root of a squared?
A.
Logically, what times itself makes a squared?
A.
Okay, but here's the one little wrinkle with variables. Remember we said square roots have to end up with positive answers? Can you all guarantee me that that a represents a positive number?
No. So, absolute value.
So you have to put an absolute value on it to guarantee that it will become a positive number. Yeah. Well, it's going to get to be more of a pain here. Because sometimes you put the absolute value on and sometimes you don't. Because, for example, here's another one. What times itself makes a to the 4th?
And it's not necessary to put on there
Because a squared times a squared is a to the 4th. Why is it not necessary to put an absolute value on it? Yeah. Some squared's always positive. So if it's got an even power on it when you take it out of the root, it doesn't need an absolute value. Okay, so we're trying to create a rule here. What times itself makes y to the 6th?
And you have to put the absolute value. Yeah, and you have to put absolute value.
Because y to the 3rd times y to the 3rd would add to make y to the 6th, wouldn't it? So yeah. And since that's an odd, it could be negative, so yes, you have to absolute value it. Okay, now I want you to notice. What have we done to find that power each time on the outside? You started with a 4, you ended up with a 2. Started with a 6, you divided by 2, because 2 is that index we don't write, but you're dividing by the index. 6 divided by 2 is 3. So therefore, if I go crazy on you, and suppose I give you z to the 20th in a 5th root, yeah, 5 divided into 20 goes in there 4 times. Do I need an absolute value? Why? It's an even power, even number power, so I don't need it. Okay, so what if I went insane? I gave you a 12th root of h to the 36th power.
H to the 3rd?
Okay, 12 goes into 36 3 times, and since that's odd, I would absolute value it.
So when it's odd, you automatically.
Not quite yet. Okay, you'll notice all of these divided it perfectly exactly. What if they don't divide exactly? Oh yes, I would. It's not that bad. Okay, suppose I said do the square root of x to the 5th. I'm going to put the index on there so you see that index. Okay. I'm going to do it the long way this time, then I'm going to show you the shortcut.
Why don't you just show us the shortcut?
Because it won't make sense now. I need it to make sense.
Try.
So, just like a few minutes ago when we broke down square root of 24, we broke it into 4 times 6. Okay, so technically what you do with variables, I'm going to break it as x to the something times x to the something.
X to the 4th times x.
There we go, x to the 4th times x. Okay. The index is 2. It'll divide into 4, won't it? 2 goes into 4, so we'd have x to the 2nd on the outside, and the x on the inside doesn't get to come out and play, so it's stuck inside. And that's nice. You can break it down like that. Works. But now watch the magic. If I had done 5 divided by 2, how many times does 2 go into 5? Twice. With a remainder of 1. correct? 2 went into 5 twice, the power we took out of the root. The remainder on the inside of the root was 1.
Wow.
Works for everything. Yes.
Redo one.
Let me do another one here. Suppose I gave you a to the 7th, b to the 11th, and a cube root. You would go, how many times does 3 divide into 7? 2. So that's what you can take out, but what's your remainder left over? 1. So that stays inside.
Okay, if you do that again, just do that real quick again.
3 goes into 7 twice, that would make 6, right? So my remainder would be 1.
Okay.
One more time.
So 3 goes into 11
3 times.
3 times, which would be 9,
Reminder.
a remainder of 2. Now, do I need an absolute value on anything? Okay, by what we've been doing so far, you would think, yes, the b to the 3rd should have an absolute value.
All of it.
But all of it.
No.
No.
Here's the wrinkle here. Okay? Look back here at this z to the 20th over here on the left. Oh, whoa, I'm like overtime.